Yeah, this slot is around the right storage for OpenStack, specifically block storage. Since we have a limited amount of time, I assume all of you know around OpenStack and are familiar with it. So I'll more focus on the technical aspects around SolidFire and the integration with OpenStack. But before I do that, I would like to briefly have an overview in our portfolio, then go into a little around Cinder, and then I would like to demonstrate how the integration between OpenStack and our platform would function. As we're limited of time, I'm going to continue. This is basically a view of our portfolio when it comes to the various products. NetApp is well known for our data on tap based systems. We have been engineering this platform for the past 25 years. It's an enterprise architecture with software initially combined with hardware, and now we're selling the software separately as well. Recently we have acquired SolidFire, recently a year and a half ago, which is a company which was founded in 2010 and is now a part of the next generation data center portfolio within NetApp. EF series is part of the LSI acquisition. We acquired the disk drive division from LSI. It's very fast, very dense storage, but not a lot of data management capabilities, which the other two platforms provide. But ideally works, for example, in acceleration of single application stacks like Hadoop or such deployments. Also fits very well underneath Ceph, for example, as a storage expansion. Storage Grid is our own object storage, everything you'd expect from object storage, S3, target, policy-based and lifecycle management around data. AltaVault, which is our cloud gateway, providing the ability to back up to an object store, ideally one of ours, but clearly others are supported, and the external, the Amazon one is supported. And OnCommand is our management and capacity management tooling. And with all of these products, we have an integration within, let's say, the various projects within OpenStack. For data on tap, we are a multi-protocol platform, so we provide multiple protocols, and therefore, for example, you would see Cinder and Manila. Manila is the file-based project for file access within OpenStack. It's actually started with us a couple of years after Cinder was started. Swift object storage, this is the mapping of our products. And today's session is around SolidFire specifically. We have other session later today specifically around the focus on containers, but this is SolidFire in combination with OpenStack. And just to illustrate, OpenStack is like boerenkool with worst, and boerenkool with worst is a typical Dutch dish, and we like mashed potatoes with the green stuff and the sausage. And I changed it from an American slide like it's a sandwich with peanut butter and jelly, which would resonate less, let's say here. But it kind of goes very well together. And to tell a little bit around the history of SolidFire, the founder of SolidFire was a gentleman called Dave Wright, and he was working for a company called GameSpy, I think 2003, 2004 timeframe. And he was responsible for the technical infrastructure and the software underpinning the online gaming services they provided. They got acquired by a company called IGN, which is still a large online gaming platform. But he did not went along with the acquisition, and having seen the opportunities on providing services on the internet, he started his own company called Jungle Disk. And Jungle Disk was backup to the cloud and Dropbox type functionality. And he did two things. Not only he created the technical offering with his team, but also he built a very successful company. And the company was successful as such that Rackspace acquired Jungle Disk, and the services provided with Rackspace became part of the managed hosting offering of Rackspace next to the colo. And at that point in time, he was part of the organization looking after the managed hosting offering of Rackspace. And basically, they were looking how to cope with the upcoming competition from Amazon. right? Amazon providing a self-service portal, very easy to consume resources. And yeah, they face this as competition. How can we build basically the equivalent for our own? And this is where they, together with NASA, started OpenStack. And at that time, the founder of SolidFire was at Rackspace. And they were looking, okay, if we're starting this project for great automation and orchestration, what do we need at the various layers of the infrastructure, compute, network, and storage to be able to fit in there? And this is where he came up with a list of requirements, and specifically for storage, he was looking to buy a platform in the market. And yeah, basically from all of the established vendors, he couldn't get it, not from NetApp, not from the others, but also from the startups from that moment, he could not get a platform which provided all of the functionality he needed. So basically what he did, he from his technology heart went away and started his own company in 2010, which was SolidFire, and basically built the storage platform. And initially selling into service providers where IT is the business, and later on selling into companies like software development or with web presence who take advantage of the platform. And one of the big bets they also took early when the product was developed, and also the let's say the years after, was looking into OpenStack. So typically, prior to acquisition, I think 50% of the SolidFire business was OpenStack related, 30% VMware, and 30% let's say the bare metal systems. And one of the things he did is about the Cinder driver. When Cinder moved out of, or basically block storage moved out of Nova, they put in a lot of effort to make sure that not only the generic driver was developed, but also our specific features of SolidFire were part of the native driver. Yeah, we dedicated engineering resources and were leading the project, and still actually one of the guys who was leading the project, John Griffith, is still a NetApp employee through the acquisition, so he's still here. So also if you would like to see changes in the Cinder project, yeah, we can easily bring them into the group and see if we can put them upstream into the OpenStack distribution. Lots of contributors now, and many vendors representing there. So what were these specific features for SolidFire? It's the way we built the platform. It's the way we do scale out, and it's basically an N+1 architecture. Beyond the initial 4, you can scale with single increments. And we do automatic load balancing of the data in the infrastructure, so all nodes are equally burdened in terms of capacity, but also equally burdened in terms of the workload, right? And this all happens transparent to the virtualization or server layer. The guaranteed performance, which is if you're building a cloud infrastructure and you need to facilitate a lot of workloads, and a lot of workloads which are unknown, it sometimes can be difficult to control performance, not having one tenant or one application eating all of the resources away. And this is what we provided a storage layer to really enforce the storage quality of service. And normally, storage quality of service is very immature compared to what's happening at the server and network layer. And this implementation is really and allowing not only putting a ceiling on the throughput or IOPS, but also providing minimum guarantees within the platform, so you can really consolidate many unknown workloads on a truly shared platform. And it was designed to be managed from elsewhere, right? So it was designed, the first 3 versions of the product only had a REST-based API. There was no GUI. There is still no console to log on. It just operates through the API with the various toolkits, SDKs like Python, for example, but also Ansible, Puppet, Chef, those tools you can utilize to manage this platform. And now for demoing, there is a GUI, which is fine for me today. Another item is we don't use typical RAID technology, so we use our own data protection scheme. And this enables, let's say, fairly fast rebuilds, right? So if an SSD drive would fail, because it's an all-flash platform, in normal platforms, the rebuild could take hours, and if you would spinning disk, it could take even longer, and we've all experienced this, I guess. And in our platform, a rebuild of a drive is done within 10 minutes, and an entire node failure is restored within the hour, right? So this also gives you a thought of maybe have a different look at your support contracts when it comes to hardware. And with this, the architecture is also that we maintain quality of service to your application while component failures are happening in the infrastructure. So we're always honoring the minimum guarantee towards the application, for example. And the last, it's a bit of a boring topic, but if you're starting a new platform for data management, you're doing this in 2010 timeframe, the choice is disk or flash. It's going to be flash, and to make the business case work, we have data reduction technology, always on thin provisioning, always on inline deduplication and compression without performance impact, and it's just there. It's nothing to manage, and just to know it's there. Many of the examples, if we would meet or have other sessions, are with 3 or 4 nodes, right? And it's relatively simple hardware. It's 1 U compute nodes, Intel architecture, 10 SSDs per node. Each node is equipped with dual 10 gig E, which go to any top of rack switch. And from there on, the software running on each node would create an individual copy, would create the cluster. But all of the examples are 4 nodes, and I want to give you a feel of the scale we can get. So we can get to 100 nodes for such a cluster. And while adding nodes or removing nodes from the infrastructure, the data and load distribution towards the newly added nodes or the nodes you remove will happen automatically without any reconfiguration from a server perspective. Also, it's a controllerless shared nothing architecture, right? So you will always scale capacity and the related performance hand in hand. So for example, if you would have 100 nodes, you would have 1,000 drives. In this configuration, we have more CPU cores than we have drives in the platform, right? We also guarantee a certain amount of performance per node. So we have nodes which are tested and guaranteed for 50,000 IOPS, and we have nodes guaranteed for 100,000 IOPS. And you can combine these in a cluster and basically pick and choose in terms of our capacity points and performance points the type of nodes you would be adding into the cluster or taking out. And we have a guarantee program which also facilitates the compatibility and therefore future lifecycle management actions, for example. Then a little, as I mentioned, it's a block platform. What we often see is the conversation block versus, no, I'm not here today. Object storage, right? We have our own object storage platform and we have our block storage offerings. Now, specifically the applications we would see around block storage, it's more of the production workloads, and clearly there are alternatives when it comes to block storage in the open source as well. But in many cases, we actually see that many customers would start with the open source equivalents for iSCSI storage, for example. But when they move to production, we often see that if the performance SLA needs to be guaranteed, the availability needs to be guaranteed, that SolidFire is, for example, added to those types of deployments. And this is more performance focused, supporting your production workloads, and object storage or the other alternatives might fit better into capacity-oriented workloads. So, conscious of time, a little around the releases, right? So the first was Bussum, where we had the core functionality around the integration with OpenStack, and from there on we kept on innovating and developing in the Cinder project. And what you actually see is that many of the functions are SolidFire first, right? And which are part of the upstream code and in every distribution. But many of the functions we put in the Cinder driver are SolidFire first, and then a release later, they're either removed because it's, the community decided to do it differently, or they are exposed to other vendors as well. So in this case, up until the Mitaka release, we're adding multi-attached volumes and replication, for example. And now to give you a little feel about, let's say, the ease of integrating SolidFire storage into the OpenStack environment. So if you would set up a cluster, which is an easy task, it would take you half an hour rack and stack and 5 minutes of software configuration. And from there on, you have a standard administration account. You could utilize that one or create another administration account. adding in a few lines of code I will show, or a few lines of configuration parameters in the Cinder.conf file, and enable it as an additional backend, restart the process, and from there on you'll be managing the entire system through OpenStack. So there is no need to pre-configure network ports, to pre-configure RAID groups, or pre-provision LUNs or set up the backend. So right out of the box, you will be able to utilize this platform. And to show this how this would work, I would like to quickly show a demo. I need to change this. 1 moment. Display. Yes, this works. One is the, let's say, the man pages within these, if this is visible, yeah, these are actually, this is all you need to add to the Cinder.conf file. So in the black box, it's, what is it? 5 lines of configuration parameters. That's all you need to add into Cinder.conf. And there are no specific drivers needed on the Nova compute nodes or whatever. You just add this into Cinder.conf and enable the multi-backend, and that's it. We have some specific SolidFire parameters you could add as well, which are not necessarily, but make life a little easier. And yeah, as said, these are the supported standard configuration or standard functions, and we have the ability to manage the quality of service also completely from an OpenStack perspective. So logging into OpenStack, Horizon, there we go. I'm already logged into a SolidFire cluster, and from a volume perspective, there are a few volumes there which are already from previous sessions, and here I am in the dashboard. Something to consider if you would create a project in OpenStack. It correlates to what's happening at the storage layer. So what I mean by that, if you provision storage in a SolidFire platform, you always map it into an account for reporting and who uses what purposes, right? So, for example, if you have the admin project, in this case, the admin tenant project ID, on the cluster, if I would go into accounts, you actually see that the UID of 85897 is automatically created as an account on the storage. So it's very easy to correlate what's happening at the OpenStack layer and what's happening at the storage layer. That's one. Then, if you would go into specific the storage bit, you would have volume types. So you can actually specify a certain class of storage, if you will. SolidFire enables the ability to define the tiers you would have in the past, like SATA, SAS, and Flash. It's all Flash, but you can still define your tiers, gold, silver, bronze, and enforce it in the software. It's truly software-defined software. And you can manage or associate a quality service spec to a certain storage class. So I would add a volume type. Let's do OpenStack Days Benelux. Create volume type. Here it is. Now I would create a quality of service specification, and this is all standard OpenStack functionality, so there is no specific drivers or code needed to make this happen. But I would say min IOPS, for example. Let's say performance. This is the name of the thing, backend. So there is the quality of service spec performance, manage specification, create a key, min IOPS. Let's make it 1000. There we go. Add in another one. Bear with me, I'm going to add another 2. Maximum IOPS. So this is the ceiling. I'm going to make it 2000. And do another for the burst level. And let's do the burst level of 20,000, or let's make it 18,000. There we go. And now I can associate the performance tier I've just defined and manage to our profile of today. So that's the performance one we just created. And then I would say associate. So now, this from an administration perspective, if we would provision a volume, we could associate a certain volume type with it. Just have a quick look on the CLI for this. So Cinder list, you see the volume. If I would list a Cinder type list, I would get the volume types. Here's the one I just created. And if I would say Cinder calls list, come on, sorry. Then we actually see the performance tier I've just created as well, right? So you can manage it from that perspective. This is all standard OpenStack functionality. Now, let's provision a view. So the admin creates the service catalog, the portal, which you are going to expose to your consumers. And the consumer would always start a project, and let's say I want to provision a volume, create volume. I would say Benelux. Could give a description. I'm not going to take an image, but I could take an image and make a bootable instance as well. Let's say I'm going to start with the bronze one and make it 10 gig. I have only one availability zone, but normally you could choose your availability zone here as well, where to provision. Create volume. Volume is created. Name Benelux. But if I would go into the volume, then I would also see it's got a UID, which everything gets assigned into OpenStack. So now if I would go to the volumes on the storage side, it's 57D3, and we actually, if I would hit refresh, should say 57D3, right? So it's very easy to correlate what's happening in OpenStack and at the storage layer, and it's done in this specific project. So yeah, should you do accounting or other stuff, it's very easy to fill your environment. From a quality of service perspective, this volume has got 750, 1250, and 2500 IOPS, which we really enforce, and we were happy to show you if we would have more time. Now I would like to focus on the management bit from an OpenStack perspective, and let's say I have this workload and suddenly it moves from dev into production, and I gave it a lower quality of service in development because I want to have clean code and I just want to enforce to make sure the application works at a lower performance level, but now it needs to move in production and I need to update the quality of service spec. So I would go into this view and I could say, well, this is my volume, let's change the volume type. And suddenly I could say, well, it's now on the lower tier, but take the one we just defined. A migration policy is never, because we're not going to move data from slower disks to faster disks. No, we're just going to enforce the policy. So we do not have to move the data and then change volume type. Volume type will get updated, and clearly this should read at the burst level now 18,000 IOPS. Hope stuff works. And there you go. It's been upgraded, right? And all of it is managed solely through the OpenStack interface. So as said, there is no additional drivers required. I can show you the stuff we would have to do in or add into the Cinder configuration file. So there you go. I've added a little of the specifics with the SF prefix. So you see actually the specifics on the SolidFire, but the other ones, the 5 I just showed you in the documentation, are the ones you need a bare minimum to operate. And a little higher you'll see the multi-backends. I don't see it, but you have to enable the additional backend as well, and they need to correlate. You have to call out specifically SolidFire. And this is the ease of use, if you will, using the storage with OpenStack in this perspective. And yeah, basically all the operations like snapshotting, cloning, glance image caching, all of those functions, yeah, you basically just use the OpenStack framework and don't require additional work or additional drivers. So there's also never the issue to update driver. Should you install a new release of OpenStack, we're upstream in every distribution, unless we're deliberately taken out. But yeah, it's there. So any questions around this already? Oh yeah, 3, but I'll get to you first. Yes.
You specified 10 and I saw 10.7. Does it align on cylinders or something like that?
So that's the difference here. Yeah. I specified 10. So in OpenStack everything is base 2. In the storage it's base 10. Sorry, it's the other way around, yeah. But that's the difference.
Oh, of
yeah.
course it's SSH. Yeah.
Yeah.
Thank you.
Yeah. And, you had a question at all?
Yeah. So in this configuration it says iSCSI is used, right?
Yes. Yes. It's we use the iSCSI protocol, and yeah, basically there is some advantages there. We take advantage of some functions in the iSCSI protocol, which you might know as iSCSI redirect, and that's basically you do not have to configure multipathing. If a node dies, we just move your iSCSI session to another node. So that makes the ease of configuration, and it's much better suited to build a true storage scale-out platform. Right? We do have fiber channel support as well, but the deeper integration with OpenStack is centered around iSCSI. Yeah. You had a question?
Before you showed the compatibility matrix, right? Which products contribute?
At the beginning, right?
Yeah, exactly. What part of the SolidFire driver, let's say, specific to SolidFire? I mean, we have the same capabilities with the E series or with the OnTap than with the SolidFire one. And the second question is, are there other solutions from NetApp which are not purely flash-based to do something similar? Or why only does SolidFire only do flash-based?
So SolidFire is the question is, you have a wider portfolio, and correct me if I'm wrong, with products, E-Series, OnTap, and SolidFire, and others. And the functions we just showed you with OpenStack and SolidFire, is this also applicable to other products in our portfolio? So all our products work with OpenStack. And some of them have integration like this, others have integration which require a little bit more work, but they will all function with OpenStack. And if you look deeper into the platforms, then there is a fundamental change. Like our E-Series platform is a platform which is built for speed and built for density, but not providing a lot of data management capabilities. And that's usually being deployed to accelerate a single application stack, right? Which could benefit from the performance, but you take all of the data management capabilities from, for example, the database level. Data OnTap is a platform which supports multiple disk types and supports multi-protocol. So should you want to use NFS as a protocol, we would definitely go with Data OnTap, which is our flagship product and will remain our flagship product for quite some time. Now I need to speed up. E-Series, SolidFire is a platform providing iSCSI connectivity, quality service, but the way we do scale out is very unique compared to the others. So it's a web scale architecture, where the other is a enterprise architecture. So those are the differences, but we put a lot of effort to make it work with OpenStack, and this is actually the easiest we have. Yeah. All right, I need to finish, and I will. I just want to make sure I will skip on the customer case, but there's no other way to utilize or to manage the platform. No libraries needed. It's very easy. Also, the iSCSI setup is very easy, and I would encourage you to visit the brewery, which you can find on NetApp.io, NetApp.io, where we not only have a well-rich filled GitHub for all of our platforms, but we also publish what we do with OpenStack, what we do with Kubernetes, with Docker. We're having a certified Docker plugin for all of our platforms, and stuff when we get in or integrated in other platforms like native support in Ansible, for example. All the stuff will be published on this site. So have a look. Very rich and a lot of stuff you can find there. Thanks, everyone.